Intermediate Algebra, Section 9.4. Looking at the properties of logarithms, these product, quotient, and power rules not only go this direction to separate them from a multiplication into an addition, we can also go the other way. If we have a sum of logs, provided it's the same base, we can express it as a single logarithm. And that's what this section is dealing with. They're asking us to express the following as a single logarithm. So we'll go the opposite direction as we were doing before. When you have the sum of logs with common bases, it means that they were originally multiplied together. So if I just look at these first two terms, this would be equivalent to the log base 3 of the factor 12 times x plus our log base 3 of 2. These two logs are added together. We have common bases. And going in the opposite direction for our product rule, a sum of logs is the same as the product of those factors. So we have a 12 times x times 2. And simplifying, at least the 12 times 2, using commutative property, our single logarithmic equivalent would be log base 2 of 12 times 2, 24x. In the next problem, we need to watch our order of operations. We have multiplication before subtraction, and if we just look at this first logarithmic form, we can use the power rule. If we have a coefficient, an equivalent expression would be log base 4 of x to the 6th power. Now we have common bases on our logarithms that are subtracted, and a subtraction comes from the quotient rule, which means the first term is our numerator and our denominator is the second term that's being subtracted. So an equivalent single logarithm for this expression would be log base 4 of x to the 6th divided by 9. In this next example, they're asking us to express this as a single logarithm. Same thing again, we're going to watch our order of operations. These coefficients become exponents when we use our power rule. So replacing the first one, this would be log base a of 2 to the 3rd power. The 6 will become the exponent on the y, and the 1/3 will become the exponent on the z. Simplifying these, 2 to the 3rd power, 2 times 2 times 2 is 8. I can't do anything with y to the 6th power, but we could replace z to the 1/3 and call it the cube root of z. Then we can start left to right with our adding and subtracting of logs, as long as they have the same base, and in this case they do. We're adding logs, and from the product rule, those expressed as a single logarithm would be the product of those two. So we have 8 times y to the 6th power. We're down to one last step. We now have a difference of logarithms with the common base. We can use our quotient rule. That means as a single equivalent logarithm, we would have log base 8 of this first quantity acting as our numerator over the denominator of this second quantity, which this is the cube root of z.